Everybody, my name is Paul Saxman, and welcome to this week's Google Maps Developers Live. With me today is visualization expert Brendan, Google Maps visualization expert Brendan Kenny. And today we're going to go over like a series of visualizations we did just last week, actually, with the Google Maps API. Show you kind of how, how the process worked, kind of show you a little bit of the code about how we built these visualizations. And just kind of go from there. So the visualizations include things like heat maps, symbols, and then we're going to talk again about Brendan's Canvas Layer API, which is kind of the ultimate visualization API. Before we dive into that, though, a couple quick announcements. If I go over to the Google Developers blog here, two things that we announced this week. One is that the Google Places API Developer Challenge, we've extended the deadline for submissions. A lot of developers were asking for a little bit more time, so we were happy to oblige. Applications now, submissions aren't due until the end of November. So November, I believe it's November, how many days in November? 31st. 30? Something like that. The other thing that were announced recently is two new APIs for enterprise users. One is the Google Maps Geolocation API, which enterprise users can use to get geolocation without using GPS coordinates. So it's based on Wi-Fi and cellular towers. The other one is the Google Maps Tracks API. It allows enterprise developers to actually store geolocation information and provides store and actually display geolocation information and analyze that data on a map. So it includes a nice feature, a geofencing feature, which a lot of enterprise customers really want. So with that, I'm going to hand it off to Brendan. Brendan's going to talk about this wonderful data set that we worked with and kick off some visualizations.
Sure. So we were looking for an example that we could just have a bunch of different ways that we could look at a particular data set, a single data set, and just some of the different ways that we can use the Maps API specifically and some of the new visualization features that were introduced over the summer to explore all the different facets of this data. And we happened to come across this really great data set. We can take a look at the website here for the Climatological database for the world's oceans, and I think it has a French name that is abbreviated there that I actually don't know what it is. And as you can see, it's an awesome website, and an EU grant paid for this group of universities and I think a few other institutions to actually go back and look at ship logs from 1750 to 1854 and actually digitize them so that you get things like latitude and longitude for particular dates. And then they actually included weather information as well. From the beginning, they included wind, speed, and direction. And then they also, as time went on and technology improved, for instance, getting reliable thermometers, they actually started including temperature information. And the reason they were doing this is so that they could push back data for their climate models, or for climate models back centuries, because while there was land-based readings at that time that we still have records for, there was no actually digitized records for the oceans, which is obviously a huge driver for, or kind of feedback loop for the climate. And so they actually went in and they did a really good job, and it's actually quite impressive how much work they did. You can see some examples here of the kind of beautiful logs here, but you can imagine that OCR is not going to work for digitizing these things. And so they actually had people go back and digitize all these things and make sure that the values were reasonable, and they converted all the different wind scales that were used by several different countries at the time. And they ended up converting, they got about 245,000 data points for latitude, longitude, the date, and the wind speed and direction at least, and then a couple of extra data points.
And also like some narrative information.
Beyond that,
well.
yeah. So they got some great narrative information about things like pleasant breeze this evening, things like that. So
which we haven't started analyzing.
Yeah, we haven't. We were talking about what's it called?
Sentiment analysis.
There you go. Yeah.
One quick thing about the data. So you said there's 250,000 data points, and how many countries?
So there's 8 different countries, and it's not evenly spread. So they digitized a huge number of Spanish logbooks and logbooks from the UK, was it the UK already by 1750? I don't know. But
That's
anyway,
a good question.
so and then then there's on the other side of the scale there's like 51 data points for the U.S. There's like one voyage where they kind of came to Europe, I think, and then came back. And so it's unevenly spread, and then over time it's unevenly spread as well. So some years I'll have a few hundred, and some years I have up to about 8,000 data points. So it actually makes for a good challenge in terms of trying to find good ways of visualizing across that larger range of interesting data points. And do we actually have the data somewhere?
Open up data, and then sample data. Oh, actually, no. The entire data set I didn't load today.
So it's kind of this. It's almost this comma separated value CSV file format, but not quite. And so it's kind of a pain to get into a certain format. But it ends up not being that hard. You kind of take column A, column B, and add them together, and you get the date and that sort of thing. And you have to kind of normalize across some of the ways they store like tenths of a degree and things like that. But in the end, we actually started with a data format just that it would be extremely easy to put on screen and be able to see, like, if we've done something very wrong or if their data seems reasonable. And our goal at first was just to see what we have. And so we wanted to put something on screen as quickly as possible. And so we made this first format that you can see up here at the top, which was just, we sorted by year, and then we took a list of all the coordinates of all the ships. We weren't doing any kind of individual ship tracking at this point, and just put latitude and longitude in these giant arrays of points associated with a year. And with that, we then went over and we actually used the new Heatmap library, which is part of the visualization library of the Maps API, and just so we could put it on screen and see as quickly as possible. Oh yeah, it's right here. What it looked like. And so this is what we ended up getting. We have here the world, obviously, and spread out over the world, you can see all the different data points just drawn extremely quickly to see where things are. And you can actually get a nice sense. Well, we can zoom out a step here, and you can get a sense of density. So you can see where you especially have traffic. And obviously, you can see already that people stay really close to the Cape of Good Hope because of kind of the winds and currents down there, whereas they're much more spread out over the North Atlantic due to kind of the different countries that leave the Atlantic here.
And you kind of see a couple interesting things too. Like, I mean, you could kind of assume that the origin or kind of the destination of most of these voyages was Europe, because where the data is centered around. But then also you can kind of see the major kind of trading hubs in the east.
Right.
You have I think Singapore's in there. If you kind of go over there, maybe Indonesia, Singapore,
up into India.
Yeah, India as well. So
obviously there's no Suez Canal yet.
Yeah.
And then so there's actually a text box down here where we can actually change the year. So if we want to see 1756, 1757, and you can see you can definitely see traffic increase, and you can see all of a sudden now we have quite a few more destinations in South America, and you'll actually see that increase. So if we pick 1780s, we can see kind of a bigger spread. We even have something off the west coast of the United States, and down here all the way down to Chile, or well, almost. So that gave us a good start, and the heat maps are great. This is something that's literally, we actually can take a look here. So first, to load the heat maps, so we don't want to bloat the main Maps API library. A lot of people don't make a map and put a heat map on it. So we wanted to make it an optional download. So you can see here on the URL, you actually add an additional parameter, libraries equals visualization. And this tells the Maps API to also load the code for the visualization library. And at that point, you get some additional classes available to you. And in this case, we're going to use a new heat map. And so here is actually the constructor call for the heat map. You just say new heat map layer and pass it data parameter. And in that, you pass it an array of lat longs. And so in this case, we actually have just this heat map, and we select on 1750. The only slight kind of tricky thing here is we had to convert to actually explicitly the lat long objects. But other than that, it's really dead simple. Like this is the entirety of the code. Like half of this code is just the year selection text box at the bottom. So that's the great thing about the heat map libraries. You can just drop it in and instantly get a picture and get a great sense of where your data is, what it's doing. But there are issues. So first of all, you can see like the colors are kind of, they blend in with the blue because we're on the oceans as opposed to the land. They're a very typical heat map color, so you can actually get a sense of, building up to the kind of red intensity. But it doesn't necessarily stand out. And the other thing is this idea of dissipation of points. Mm-hmm. So here at this zoom level, you can still get a sense of continuity between points in the logbook. Usually they were about a day apart. But when ships were really going quickly, you can see that they start to spread out. Now this becomes a bigger problem as you zoom in because heat maps are a measure of density. As you zoom in, you have more space and fewer points per unit of space. And so you actually have the points spread out more and more until you get to the point you can no longer tell kind of continuity between points. This is expected because heat maps, I said, are a measure of density. This is expected, but it's not necessarily the optimal way of displaying the data that you necessarily want. And so there's a bunch of things that we can actually tweak here. There's a bunch of knobs and levers that we can use to make a heat map our own and make it very specific to our data. And Paul is going to walk us through that.
Absolutely. So so from here, we kind of recognize these not necessarily issues with the visualization, but ways that we wanted to kind of go and tweak it and make it more informative to the user. So first thing we did, so going back to our heat maps, is so we actually simplified the map itself. So a few things we did here is we went into terrain mode, for example. So we felt that like the actual road map wasn't the most valuable way to kind of visual or see the map, just because at that time most of these roads didn't exist. And we were more primarily focused on kind of the countries, which was the information that we wanted to see. So the other thing is actually, if you notice for example, on the left-hand side here, we actually removed most of the controls. So the only real control we wanted was the zoom control, and then this control down at the bottom. And this one is a little bit new. I'll explain that in a second. The control on the bottom is actually a slider that we put in, or a range input box. So a couple other things that we did too to this. So we simplified the map, we simplified the controls, and we actually tweaked the heat map a little bit. So you can see here is one thing is that we turned off dissipation. So as we zoom in, the heat map no longer dissipates as the points get more spread out. And that's a nice feature here because what we really want to see is kind of these tracks, or kind of these voyages. And this allows us to kind of retain that information at any zoom level. And
it's a trade-off, right? So as you zoom in, the heat map spread gets quite large relative to what you see on the screen. So that doesn't necessarily represent kind of the ship, but on the other hand, you get continuity between the zoom levels. And so it really depends on the data that you have. If you know very precisely every single point and you're interested in points as opposed to tracks, then you might not want to use dissipation.
Yeah, exactly. So like for example, to kind of emphasize this point, I can't necessarily say exactly what port or what city this boat was in when they were actually taking these samples. I can kind of assume they were in Dakar, but not necessarily. So, but if we had dissipation on, things would actually kind of align more better with the map. So maybe a nice feature to have kind of a toggle for that. So in terms of the control, so we noticed that a lot of these voyages actually span multiple years because they were sailing or steamships. So we wanted to kind of give the user a way to actually visualize the data over time. So this was something we did with this custom control on the bottom. So this is just an input range box. And what we do is every time that, as it slides to the right or to the left, we actually pick a different date range and display it on the map. And this kind of shows how quickly these heat maps can be rendered, because each of these are being rendered dynamically as the slider's being moved. It's not exactly real time. I mean, if I grab it and try to slide it all the way to the right, I mean, there's a little bit of lag, but it's actually pretty good. And this is on a relatively new hardware, so also keep that in mind if you're building one of these. You should make sure it works with older hardware. So if we go to the code, so this is heat map 1. If we look, let me go back here. So here we see a couple of things that we pointed out. So again, the code's fairly simple. Disable all the default UI controls, add in the zoom control. So I'm a bit of a minimalist. I like to actually remove everything and then add back only what I need in my interface. And down here you can see with the heat map, I actually set the dissipation off. And this is something we didn't mention, radius. So radius, you can actually control how far the each point actually spreads out on the map at default zoom level. So here we're saying a radius of 2 pixels. Everything else, one other thing, this was actually in the previous one, is instead of actually having these map controls actually outside of the map in the HTML DOM structure, we can actually use the Maps API to actually put it in the map itself. So you can see here is this div with the sliders actually down here in the DOM tree. It's actually below the map in the DOM tree. But here by calling map and then adding the controls, we can actually push it into the map itself. So from there, we thought this was a pretty nice visualization. I think we're kind of seeing a lot more. So the next step that we took, though, is to kind of tweak the visualization a little bit more. So again, I mentioned that we can see these actually multi-year voyages. So we wanted to kind of emphasize or give the user the ability to kind of see these a little bit better. So here I allowed the user to actually set a year range. So there's a maximum of 10 years. Here you can see that the visualization actually updates a little bit more slowly as I scroll to the right. And that's because we're dealing with a pretty massive number of data points. I think at this point we're probably rendering, I don't know, somewhere, so it's 10 years, it's 100 years total, 20,000 plus or minus data points. But since we can expand this out over 10 years, we can actually see these multi-year voyages forming up in the Pacific, for example. And actually, we see a lot more, get a more stronger sense of density in the Atlantic, in terms of where these ships were going. This is a really interesting area here.
Yeah, you get much prettier little gradients, like around Northern Africa there.
Yeah, I mean the data really pops out more, and I think this is really interesting. 1776, 1786, you can see a lot more activity down in Brazil and Argentina. So. Again, I think this data was hosted by a research group in Spain. So I don't know if that necessarily affected where they were actually sampling from. But so we really like that. But one thing that Brendan pointed out earlier is that the kind of this blue kind of the green to red heat map, which is a really default, pretty much standard style for heat maps, didn't really show very well on water. So if we had really sparse samples, it was didn't stick out as much. So the idea was to take the heat map. That we have the ability to tweak the heat map to make it more prominent on the map, and we did that by actually specifying a custom gradient for the heat map. So here you can see if we scroll forward a few years, I think that was in the mid to late 1700s. Now we can see these voyages that is actually probably a single ship in kind of the Pacific. This data actually sticks out relatively well on the blue background. We take a peek at the code. That's the slider. So setting up a gradient is really as simple as specifying RGB values. So you specify any number of these, as far as I can tell. And one trick with this is make sure that the first one actually has alpha value of 0, so it's completely transparent. Otherwise, that's actually the default kind of color that's overlaid on top of the map. And then from there, I think I did a yellow, orange, red. Oh no, it was actually the other way around. It was a red, orange, white gradient. So kind of fiery looking. A couple other things I did to the heat map here. So in addition to specifying the gradient, I specified an opacity. I think default opacity is about 0.6. I actually made it more opaque to actually make the data look more prominent. And I set this max intensity. So this is I don't understand. So how does max intensity work with the heat map?
So that's the ceiling value that everything gets normalized to. So normally it would, without an intensity, if you got 18 points on top of each other, that would be assigned to the max value of the heat map, and everything else would get normalized and brought down. So a 9 points on top of each other somewhere else would only have half of the intensity. So max intensity sets a limit. So 18 gets floored or clamped down to 10, and that 9 is now 9/10 of intensity instead of half.
Interesting.
So it's a way of making sure that if you have one really, so we have a couple of points where like the ships are in ports, and they have many times more points there than they do other places because they're there for a couple of weeks, and those can drown out all the other data. The other data turns to like the lowest level, and you lose all that data. So we're less interested in the ports for visualization. We want to see all the points. So you set that max intensity.
So essentially a high pass filter. So we're filtering out the high sample rate.
Yeah, I guess you could say that.
Cool. So another, again, it's just a matter of a few tweaks that we put in the code. So opacity, gradient, and max intensity. We can get a really nice effect on our map. So we're going to go to one more heat map, and then actually we might call it a day with one more heat map. Oh, actually two more heat maps. Oh, I didn't want to do this one yet. This one is a lot of fun. Two more heat maps. So in addition to adjusting the heat map itself, you have the ability to actually style the map as well, well beyond what I showed before with just kind of changing the controls and changing to terrain mode. Again, like I said earlier, we really wanted to focus on the countries and the data. So what I did here is using styled map, the styled map feature of the Google Maps API. I took everything, basically toned the map down to just show the land masses and the countries, and then on top of that I put the really intense heat map, and this allows us, kind of looking at this data here, this allows us to pretty much see every single, pretty much see everything that's going on, even though it's like a single voyage in the Pacific. We can see that actually that data is kind of pops or sticks out really nicely on this map. So the styled map API, if we go take a look at that real quick. So here I'm actually specifying the style for the map, and again, kind of the way I personally like to build visualizations. I like to turn everything off and then only add in the stuff that I really want. So here you see I've actually said the everything on the map is made invisible, and I sequentially add back the information that I want. So here I've specified that I want to show the water with basically color 0. I want to show the water labels, and here I actually have to set a stroke and fill. So that's for the color of the text and actually the what actually surrounds the text. So the idea is that if you have white text on white text on a black background, you probably want to do some kind of a stroke around it to kind of make it blend in with the background a little bit. Kind of a minor tweak. If you play around with this, you can kind of see what it looks like without that. And again, I turned the landscape on, and then turn the countries on. So and here I didn't have to do stroke and fill on the labels because it's, I think, like white text on a grayish background. Oh, and inverted lightedness. Actually, that's the trick here, is that if I inverted lightedness on the water labels, I got like a blue text on a white background, or blue text with a white stroke. And here, by default, the country labels are white on black, so I just inverted that around. So that's actually specifying the style, and you actually just set that on your map with a single line of code. So this may look a little daunting, like setting up these styles, but what we did when we actually launched the styled maps is we created this thing called Styled Maps Wizard. Basically, this tool allows you to tweak all the different settings that I showed a moment ago, in a graphical interface. And once you've actually tweaked it, you can get the JSON or the JavaScript object information out, so that you can drop that into your map. So, for example, let's reset this. I can say all. I turn the visibility to off, and I get a blank map. And now I want to say, for example, I can turn the water, turn the visibility back on, and now I get the water in my map. I can specify, do a custom color. Really quickly, I mean, you can create a nice visualization using this tool, or a nice styled map. And then when you're done, you just click the Show JSON button here, and you get all the code you need for your styled map. With that, I'm going to pass it. We were going to give a demo of symbols. We're running a little over on time, but definitely want to show what Brendan did with the canvas layer, because the canvas layer is really the ultimate tool for building these visualizations. Heat maps and symbols are great for kind of getting your data on the map kind of relatively quickly. Canvas layer, since it uses HTML5 and WebGL, is kind of you have the world is your oyster at that point. You can
Right. Well, so it's a trade-off because suddenly, instead of having like a bunch of helpful libraries that help you do what you want and have a bunch of options to tweak, you basically have to do everything yourself. So you have a ton of flexibility and a ton of performance available, but you now have to, every single pixel that you want on screen, you're going to have to make sure it is drawn yourself. There's no real infrastructure yet, and we're slowly kind of building that up. And there's a bunch of other libraries that you can bring in to do this, but
and a quick one with that too, browser compatibility.
Yeah, so browser compatibility is something that you need to worry about. It's not everywhere yet, but it is supported in Firefox and Chrome for a while now. It's supported in Opera on Windows, but I don't think Opera on the Mac has it yet. And then it's in Safari, but your user actually has to go to the Develop menu and turn on WebGL themselves. It's not on by default. And so, you have to look at the analytics for your blog, for your website. You have to think about your users and the kind of audience you want to attract, and say like, is this something that I want to support? It brings me awesome things, but it might cut out some of my audience. Or is my audience the kind of audience that you can say like, well, would you mind if you're using Internet Explorer switch just to use this, or are you going to lose them, so it's not worth it? The other option is you can use some cool WebGL thing and then just have a fallback for Internet Explorer. It's a really easy check to see if WebGL is supported on a browser, and if it's not, then you could do something that like these heat maps or some other kind of generate tiles sort of thing as a fallback, so that at least they can get a sense of the data that you're visualizing, if not the full kind of WebGL experience. So for Canvas Layer, for this example, we just wanted to throw together something really quickly to see as kind of an experiment how quickly we could get something up and running and actually usable. So what we decided to do was look at actually the wind data that was associated with these ships. So at each data point, the ships actually recorded wind direction and the speed of that wind there. And so what we wanted to see was first just like kind of how that looked. And so we have here, and it should load in a second. Oh, there it is. Kind of hard to see, but it's there. So what we have here is our ship tracks, and what we're doing actually is we have a ship position, and we're actually looking 3 days into the future and 3 days behind as kind of a window in time to see kind of what was wind like around this point in space and time. And so with the idea that over a few days, the wind is probably at least somewhat consistent, especially ocean when you're much more dominated by like trade winds than kind of the local weather. And so it turns out it actually is, you get some really nice coherency with the wind information. And you can see actually here, so here's a ship traveling southwest, there you go. And you can see kind of the actual wind direction that actually looks like it's propelling them really well. And you can see the same thing over here. And so now we can scroll through time and see as these ships travel. The problem is we have 100 years, so it scrolls quite quickly. But you can see as these ships travel, the wind vectors fade in and fade back out. And the nice thing about WebGL here is that it can handle all. I've actually loaded all 250,000 data points at once and just said, give me this window of time. And so here you can see kind of actually a whole fleet of ships leaving and see kind of just get a sense of the wind that they're encountering. And here you can see that things are a lot more confused, and actually we're not sure yet exactly what's that's caused by kind of ocean currents or being so close to land, or maybe it's just some captains are better at actually measuring wind speed than others, that sort of thing. So we're still looking at that data. So that's pretty interesting, and it's definitely cool to see these ship patterns as they travel through time. But it doesn't really show off WebGL. While you can tell it's like extremely smooth, and it's actually much smoother than you get because we're actually animating up to a few thousand data points on screen at once, and it has no problem shifting through there. It doesn't visually kind of give us the sense that we really have a lot of power at our fingertips. You also don't get a sense of kind of what's going on in the ocean at that spot. You have a sense of maybe what did the wind the ship encountered that day, which is literally what the data is. But you don't get a sense of what's going on. So actually, if you go back to the original data, the report they did when they finished, they actually were using it for climate models. And what they did was they said, so if we assume that wind patterns typically have like a seasonal pattern, so in the winter, winds typically do this, in the summer, winds typically do this. What if we actually looked at all the data for the winter at once, all the data for the summer at once? So we did that, except we looked at kind of a much finer scale. We said, so what if we looked at all the first weeks of January at once? So all 104 years of data brought into the same kind of screen at once. And then you can scroll through a whole year in the same way, but actually have all 104 years on the screen at once. And so that's what this visualization is. So we actually can see now this is all years overlaid at once, and we're scrolling through. So we're here, now we're in February, and into March and April and May, and finally into the summer. So you can see at this level it's much more noisy, but you can already start to see certain patterns. So let's see if we can find a good spot. So already you can see kind of the typical trade winds that you would actually take straight to the Americas, and these are the ones that Columbus rode. Actually, you can see right down here, you can see this giant swoop here, and you can see really great patterns here where it seems like all these ships were actually in quite good agreement about what was going on in the middle of the Atlantic.
Agreement over a 100-year period.
Yeah.
So
that's actually pretty good, and that's exactly what that research paper found, was that actually in many places there was really good coherency. In some places you just had a ton of noise, and they weren't. It's hard to know without actually. Obviously, none of the ship captains are still around. It's hard to know exactly what was going on, and it'd be interesting to look and see if they ended up weighting some more than others. But you can see, like here off the coast of South America, you can see actually the prevailing winds stay extremely consistent even across the summer months and into the winter. You can see that they all kind of point towards land.
Can you actually see, for example, like how the routes changed, like for different years? So, for example, as it got colder in the south, was there more activity in the north?
Oh, that's actually an interesting question. I actually don't know. So, so it'd be interesting is like how much were they able to care about that, and how much were they required to kind of
just bear with it,
sail anyway, because it was like 1750.
We did see some kind of Arctic and Antarctic voyages.
Yeah, so at certain times of year they went down there, and then it would also be interesting. I haven't really looked yet at kind of summer versus winter, because I am not a climatologist nor an oceanographer, so I'm still learning about kind of climate patterns as well. But you can see up here in Europe things are still rather confused, and I'll be very interested. There's a couple of techniques in that paper where they talk about ways of kind of interpolating between these points to find not an average, because if you average out this noise, you're just going to get gray is pretty much the equivalent. I don't know what you would. It's like
averages to zero.
Yeah, pretty much. Yeah, and so that's not an interesting number. And so you want to see like actually what are there prevailing wind patterns and things like that. So this is just a start, but this took us maybe I don't know, half a day to throw together, and so this is using Canvas Layer, which we've talked about before, and it's up on the Maps API utility library if you Google for that, or if you know where that is, and it's available today. Not this example, but that's available today, and there's a couple of examples included with it to get you started, and you can start to take a look.
Yeah, so we definitely intend to kind of share these visualizations at some point. I mean, we kind of like we mentioned, we put them together in about a week's time, so it's not always the prettiest code. But once we clean them up and make sure that everything's in a reasonable shape, we definitely plan to put these out there. If you have any questions about it, about what we showed you today, definitely comment in the YouTube stream, and we'll get back to you there. And one other point is, we only got to about half of the visualizations we wanted to today. So we might do another follow-up in another week or two, maybe once we've added some more visualizations. So if you're curious about that and you think that's a good idea, let us know in the comments. If you don't think it's a good idea, also let us know, because we can focus our time on other things. So, oh, yeah, Brendan's showing one more visualization.
I'm teasing the polyline. So polylines are just as easy as the other things to do, and you end up with just some really beautiful results with kind of these tendrils appearing across the world, and you can see kind of where traffic was. These are actually colored by country of origin, so you can see the kind of diversity of different points. In some places are very much not diverse. They're very much frequented by a single country. So
yeah, pretty easy to do, surprisingly. I mean, you can see I used the same style as some of the other maps. The only trick was actually getting these polylines. Brendan kind of organized the data in terms of voyages, and then just converting a voyage into a polyline, drawing it on the map is pretty straightforward stuff. I mean, we're talking like 5 to 10 lines of code at most. So so stay tuned. We have a lot more coming on these visualizations, and we hope to share more in a week or two. You're not going to yeah, okay.
Yeah,
we're done with that.
Yeah.
So tune in later, and we'll follow up with more. Any questions, let us know, and we're happy to follow up. So thanks for joining, and catch you in another week.